In number 27, we have a biology problem. The chewing muscle, the masseter, is one of the strongest in the human body. It's attached to the mandible, the lower jawbone, as shown in the figure. The jawbone is pivoted about a socket just in front of the auditory canal. The forces acting on the jawbone are equivalent to those acting on a curved bar, shown in the figure. F sub c is the force exerted by the food being chewed against the jawbone. T is the tension in the masseter, and R is the force exerted by the socket on the mandible. Find T and R for a person who bites down on a piece of steak with a force of 50 newtons. So again, just a quick reminder in this case, technically the teeth are exerting a force this way of 50 newtons, but we're talking about the force itself in the mandible. So in this case, first of all, I'm going to put the pivot point right here, where the socket touches over here below the auditory canal. And we've got the 50 newtons of the force or the food acting on the jawbone, so it's acting down this way. Notice here we don't have an angle, but reminder again, you can actually define torque as either force times radius times the sine of theta, or you can use the other idea behind torque, which is force times d, where d is the lever arm, the perpendicular distance between the force and this. And so if you think about this one, you can figure out the perpendicular distance between the force and this would be d right here, which make this problem much easier to solve. So we're going to do torque. There's the force due to the masseter. We're trying to find that first. That we're going to call that T. Using equilibrium, torques counterclockwise equal the magnitudes of the torques clockwise. We can solve this. In this case, relative to the pivot point, the 50 Newton food force is going to try to rotate this thing counterclockwise. The mandible is going to be trying to rotate it clockwise. Solving in this numbers, so in this case again, D for the food is going to be 7.5 plus 3.5 centimeters, or 11 centimeters away. The tension here, 3.5 centimeters, converting that to meters, which gives us this. This is a quick solution, and you'll discover, the tension exerted by the mandible has to be 157 newtons. So we can write that up there. And then finally, the question is, what's the force exerted by the socket on the mandible? So we've got a downward force here. What do we know has to be true? Well, we could try different pivot points, but not really critical. We know for something in equilibrium, not only is the net torque zero, but the net force is zero. And if you think about it, we've got 50 newtons acting downward, 157 newtons acting upward on this muscle. What must this force be? Well, just by subtraction, it must be 107. And that is my other answer that I'm looking for. Hopefully that made sense. So here are our two forces.